Unit 16 Measures of Central Tendency. Contents: 16.1 Introduction, 16.2 Mean, 16.3 Median, 16.4 Mode, 16.5 Relationships between mean, mode and median, 16.6 Choosing a measure of central tendency, 16.7 Conclusion. Learning objective. It is expected that after reading Unit 16, you would be able to understand the procedure of arriving at measures of central tendency of the data collected, work out the ways of finding out mean, mode, median measures of central tendency, decide which of the three measures is more appropriate in the case of your data. 16.1 Introduction. After dealing with the skills of sampling techniques for studying large complex social groups, we would now discuss the matter of measuring central tendency and its applications. Unit 16 deals with the basic measures of central tendency and their application for those of you who may lack a strong background in mathematics. In doing so, complex mathematical variation or formulae have been omitted. Besides, a minimal number of essential shorthand mathematical symbols and familiar examples drawn from social science data are presented in a non-mathematical form. 16.2 Mean. Mean is the most common and widely used measure of central tendency. Each observation is a population may be referred as x1. Read x sub 1 value. Thus, one observation might be denoted by x1, another observation x2, third x3, and so on. The subscript I might be any integer value up to n. Then the total number of x and I value is the population. The mean of the population is denoted by the Greek letter mu, lowercase mu. Okay. Calculate the mean from ungrouped data. Mean is the most familiar and useful measure used to describe the central tendency or an average of a distribution of scores for any group, individuals, objects, or events. It is computed by dividing the sum of total scores by the total number of scores. So this is the average. M is the sum of all the values divided by the total incidence, total, where m is the mean sample and x I are the scores and n is the total number of scores, and this denotes sigma in the sum of denote the, and C box 6.1 and 6.2 for examples of 1 and 2. So here 16.1, this example 1 is the number of cattle owned by a member of a community is recorded as below. So this is the number of many people are in the community. So total how many people are there? 10 people have been taken as a sample, and that these 10 people, each people have different number of cows, cattle. Okay, so we have to find out the mean. So what we will do is that we will add all these numbers divided by sum it, total it, and that is 170 we are getting, and divided by the total number of people or members we have taken 10. So 170 by 10, that is 17. 170 by 10, that is 17 becomes the mean. This is the balance point in a distribution such that if you subtract each value in the distribution from the mean and add all these deviation scores, the result will be 0. So this is the mean value is that. What is that? Such that if you subtract each value in the mean distribution from the mean and add all these deviation scores, the result will be 0. So okay, that we will look in later. Okay, so you can understand that calculating the mean from grouped data. Calculation of mean from grouped data is slightly different from calculation from the ungrouped data. So where m is the mean, xi is the midpoints of the class intervals, f1 are the number of cases in various intervals. So total is the total number of scores for the sum of frequencies of various intervals. So this is the other variations that following the frequency 8, 9, 12, 9, 7, 5, the households in a community owing number of chickens. So arranged in 6 groups. So those people having 1 to 3 chicken and 4 to 6 chicken, and those having 7 to 9 chicken and 10 to 9 chickens, 13 to 6 chickens and 16 to 8 chicken. So whoever having 1 to 3 chickens, the midpoint of the interval is 2 and the frequency of number of householders is 8. So 8 people having 1 to 3 chickens, and other having 4 to 6 chicken having, so midpoint is 5, here the midpoint is given, here the number of frequency, number of householders having that that many chickens has been shown here. So the total number of households are become 50, and here 16 is the midpoint interval only we are taken and multiply it, so we will get this value and sum it up. So here also we will divide it by the total number of this thing, then becomes 7.52. So a short method of calculating mean from group data. There is a shorter way of calculating mean from group data which save time and labor in computation, particularly when one has to deal with a large number of cases. It involves the assumption of mean and making a guess at identifying the interval in which the mean probably falls, generally among the central groups of intervals. A different guess of these intervals alters calculation but not the mean. Mean m is equal to am plus sigma fi dy divided by total number of frequencies, okay, into I. Also d is equal to am minus x by I, where m is the mean, am is the assured mean, okay, xi is the midpoint of the class intervals, fi are the number of cases in the various, sigma is the symbol of total number, di is the deviation from the midpoint from the various classes from the midpoint of the classes having the assumed mean divided by the size of the interval. Equation 4 and is the size of the class interval. See box number 16.3 for the example. So we will look at this formula here where this is the marital distance, the distance between the villages of the fows. Okay. So the marital distance was investigated in a community, and following was the frequency. So 88, when the data were arranged in 6 groups according to marital distance, 25 to 30, who have the distance from 25 to 30 kilometer, 88 people are there. Those having 30 to 35 kilometer, 93 people are there. Like this is been distributed. So 50 people, 50 to 55 distance, 54 people have been found. So we again made the table here. Then the frequency, that is 88. What we are getting here, this is frequency is how many times, how many people are there between 20 to 35 kilometers written, and this is the midpoint. xy is the midpoint 25, and 30 midpoint is 25 plus 30 divided by 2, so you will get 27.5. So using that formula we got deviation is equal to plus 3, like that it has given. am minus, this is the am minus xi divided by I. So and f1 into d1, this is the value, the first one, okay, the first deviation you are getting plus 3, and f is the frequency, 3 into 88, so 264, and I is known as 1, okay, this is the first instance, and x is the midpoint 27.5, and am, what is am? Am is so 1 minute, df, this is the am, that is we are taken the middle of this midpoints, that is am is 42.5, so 42.5 minus 27.5 divided by, so it will becomes 42 minus 5 is minus 5, this becomes that 15, 15 divided by, this is 3, I is 3, that is what we get is I, 3 means 27, 26, 27, 28, I is 3, okay, we have to look into this calculations once again. Okay, this is divided by am minus xi, that is correct. Am is 42.5 minus xi is here 27.5, that we got as 15, and we divided that with some value, that is 5. Okay, this is 25 to 30, we have how many instances? 5 instances, I think. 25 to 25, 30 minus 25, how much we get? That is the value 5. So divided by 5, then we will get this 3. So that the calculation has been done here also. See, this is 5. Okay. How many instances? After 3 examples for calculating mean for ungrouped and grouped data, we would now discuss the technique of finding the median. So the mean value, how we are calculating, the different way of 3 different types of examples we have seen it and we have worked on it. Okay. So you can just again you can go through this, you will get more understanding. Now we will go to the other method, that is median. 16.3 is median. Median is the score that divides the distribution into halves. Half of the score are above the median and the other half are below it. When the data are arranged in a numerical order, median is also referred to as the score at the 50th percentile in the distribution. So exactly calculating, that is the center point, center value only is median as. Calculating the median from ungrouped data. Arrange the series in a numerical order, ascending or descending order. Find the median location of n numbers by the formula. So there is total, if there is total n numbers are there, n number instances are there. So we will add 1 and divided by 2 because it must be odd numbers, then only we have to add plus, then only we will get the center point. No, if we have the center value, then both sides should be equal numbers, then we will get an odd total numbers only. So that we have to add again 1 and then divided by 2. When n is an odd number, for example 7, then the value of fourth item is 7 plus 1 divided by the fourth item we will take as a median. For example, in the following order, the distribution, the value of fourth item is 9. Here you can see that is median. Whereas when n is an even number, say 12, then the median is halfway between 6th and 7th item. So we have to divide it again 12 plus 1 divided by 2, then 6.5 will be the median. So it will not be there. So box number 16 point for examples for finding the median. Where n is an odd number, then we will n plus 1, that is 4 plus 1 divided by 2, like that. 7 plus 1 here, okay, sorry, 7 here, also 3 is there, here 4, that 7 plus divided by 4. So we will get the fourth number as the median. Here 7 is the median. And when n is an even number, then even means here is the 6 only is there. So 6 plus 1 divided, and then 3.5. So it is between 7th and 8th. The order of distribution between this 7 and 8. So the halfway the value between third and fourth item, that is 7.5. Okay, this is 7.5. For that we have to add this 7 and 8 divided by 2, then thus median is 7.5. So we have to calculate here exactly, we will get that number only. Here we will have 2 numbers, so in the center, so we will add it and divided by 2. So calculating median from the group data. Finding the median score in the frequency distribution below involves 5 steps. Step 1, divide the total number n or total by 2. Okay, if n is or total numbers. Start the low end of the frequency distribution sum scores in each interval until the interval contains the median is reached. Subtract the sum obtained in a step 2 above from the number necessary calculated at step 1 to reach the median. So now calculate the proportion of the median interval that must be added to its lower limit in order to reach the median score. This is done by dividing number obtained in step 3 above the number of scores in the median interval and then multiplying by the size of the class the interval, that is n by 2 divided minus Cf and divided by I. So we will see that is an example. Step 5, this finally the number of obtained in step 4 above the exact lower limit of the median is L plus n by 2 minus Cf minus f, where L is the exact lower limit of the median interval, n is the total number of scores, Cf is the sum of the scores in the intervals between the median interval. F is the number of scores in the median interval. Then I is the size of the class interval. Graphical representations calculating the median from the group data. So there is a class intervals. So group data is that how many, see, 6, 5, 7, 5, like that. So between 10 and 2 there is 6 item is there. Between 20 and 30 there is 5 item is there, like that. So cumulative frequency is that we will add up all this 5 plus 7, 11, 11 plus 7, 18, 18 plus 5, 23, like that we will have cumulative. So from this example 6, for finding the media for a group data, we have to find the median of the following distribution. Then we have to put it in an interval like 18, 21, like that. So class interval 1, 2, 3, like that is there. Then cumulative also we have done it like this. So this is the total number of frequencies. So ZFI1 is 50. So median is L plus n by 2 minus CF minus by divided by Fi. So n or F divided by 2, that is 25. So 25 we have got n is equal to n by 25. Lower limit of the median class L is 33. Lower limits of the median class is 33. Lower limit of the median class. Oh yeah, 33. This is the median class for that. Lower limit is 33. Okay. And cumulative frequency of the class preceding the median class, that is 19. The cumulative frequency here is 19, preceding the median class, that is 19. And cumulative frequency of the class preceding the median class, that are 19. The frequency of the median class is 8. Here it is the 8 median. This is the median class. Then let us now complete the reflection. So size of the class interval 3. So this is the size of the class interval 48, 49, 50, like 49, 50. 51 minus 48 is 3. No, that is the value is the 3. Then median is equal to 33 plus according to the formula 25 minus 19 by 8 into 2 into 3 is equal to the total will we get 35.25. Let us now complete the reflection and action. 16.1 for checking if the calculation methods have now become clearer and easier to perform. After reflection and 16.1, you would learn about calculating mode for ungrouped and grouped data. So here reflection 16.1 action is that following the examples given in the text for calculating the mean and median for ungrouped and grouped data and the short method of calculating mean of group data, provided your own example of each of the 5 calculations in the manner similar to the examples in the text. This exercise would provide you an opportunity to practicing such calculation. This calculation exercise would come in handy while you would carry out your own mini research project. So this another third one is that mode. 16.4 is mode. Mode of a distribution is simply defined as the most frequent or common score in the distribution. Mode is the point or the value of x that correspond to the highest point of the distribution. If the highest frequency is shared by more than one value, the distribution is said to be multi-modal. It is not uncommon to see distributions that are biomodal reflecting peaks in score at 2 different points in the distribution. Calculating mode for the ungrouped data. The most frequent data in the series is the mode. If it can be determined by viewing the series, that if the series is small, or looking at the frequency of distribution if the series is large. See 16.6 for example 7. Example 7, find the mode of the following distribution. So serial number family 1, number of children 1, 2, 2, 3, 3, like that. 5 have 3 children. 6 have 3 children, 7 have 2 children, 8 have children, family 9 have 2 children, family 10 have 3 children. In the above example, 3 is occurs in the number of 4 times it is occurring in the most maximum times, and hence 3 is the mode of the distribution. Calculating the mode from the group data. Mode of the group data can be calculated using the following steps. Step 1 is identifying the model class, the class with maximum frequency by inspection or analysis. Then apply the following formula, that is mode L plus Fm minus F1 divided by Fm by F minus plus Fm minus F2 to I, or another is L plus Fm minus F1 2Fm minus F1 minus F2, that is this one is added, I think, and into I, where L the exact lower limit of the model interval. Fm is the frequency of model class, F1 is the frequency of the class preceding the model class, F2 is the frequency of the class succeeding the model class, and I is the size of the class interval. You can find the graphical representation of mode in grouped data in figure 16.1. So this is the mode. That's the most frequent occurring. The graphical representation mode in a group data. The sample mode is the best estimate of population mode. When one samples a systematic unimodal population, mode is an unbiased and consistent estimate of a mean and median, but it is relatively inefficient and should not be used. As a measure of central tendency, mode is affected by skewness less than in is mean or median, but it is affected by sampling more than these other two measures. Mode but neither median nor mean may be used for data or on nominal as well as the ordinal, interval and ratio scales of measurements. Mode is not used often in social or biological research, although it is often interesting to report the number of modes detected in a population if there are more than one. See example 16.7 for examples 8. Here find the model income and the basics of the following data. Income 5 to 8, the number of households 8 have the income between 5,000 to 10,000, and another people 16 people have families have an income of 10,000 to 16,000, like that's the table as given. So income in thousands, 5 to 10, that is 8. So here the medium frequency is F1 is the medium, prior to that the frequency is 15, and after to the median is the frequency is 22. So these values we can use it here. So modes lies in the 1620 having the maximum frequency is 29. Okay, this is the frequency 29, and lower limit of that is 15. Lower limit of the nodal class is 16 or 15. So 15. Okay, frequency of the model class F1 is 29. Okay, this is the frequency of the nodal class. Okay, 29. Here 16 to 20 is written. Okay, 16 to 20. That's why 16 it is written. So frequency of the class preceding to the model class F1 is 60 and F2 is 22, and size of the class interval is 5. Then using this formula we will get 18.3. The model income is 18.3, 33,000. After learning from above mean, median and mode, we will discuss in section 16.5 the relationship among the three measures of central tendency. But before going to section 16.5, let us complete the reflection and action 16.2. Reflection and action 16.2. Make a graphical representation of mode in a group data of your choice along with the line of figures in 16.1. You may then use similar type of graphical representation of group data in your own mini research project. 16.5 relationship between mean, mode and median. Mean, mode and median, the three measures of central tendency, are related to each other and can be calculated using the following equations. Mode is equal to 3 into median minus 2 into mean. So the values of the mean, mode and median are the same when the frequency is normally distributed, but their values differ when the frequency is positively or negatively skewed. So this is mode, median, and this will be same. Mode, median, mean will be different when it is skewed. Mode, median, median and mode will vary because here two modes are there. Highest time mean, median and mode will be different in this. So mode and median in various types of frequency distributions. Relationship of mean, mode, median in various types of frequency distributions. Figure 6.2 shows the relationships of mode and media in various type of frequency distribution. A, normal distribution. B, bimodal distributions, positively skewed distribution and negatively skewed distribution. Values of the variables are along x-axis and the frequencies are along y-axis. After learning about the relationship among the three measures of central tendency, let us find out how to decide which of the three or to choose for one's research. 16.6, choosing a measure of central tendency. Sometimes the researcher has to decide which is the three measures of central tendency to use. The following advice may be of help. Mean is doubtless the most commonly used measure of central tendency. It is the only one of the three measures which uses all the information available in set of data. That is to say, it reflects the value of each score in its distribution. It has the decided advantage of being capable of combining with the means of other groups measures on the same variables. For the example, for the average unemployment level in various states in India, one can compute the overall mean employment rate in India. Since neither the median nor the mode is based on arithmetic, this is used application is not possible. The precisely defined mathematical value of the mean allows others advanced statistical techniques to based on it. There are occasions, however, when taking into account of the various every score and distribution can give a distorted picture of the data. For example, marriage distance, the distance between places of residence on the two partners. In 5 cases, 40, 60, 60, 80 and 80, 800, and without the very typical score of 800 and the mean score of the group is 60 and the median is 60. The effective of the introducing the score 1810 is to pull the mean in the direction of that extreme value. The mean now become 210 and the value that is unrepresentative on series. The median remains 60, providing a more realistic description of the distributions than the mean. With this observation in mind, use the mean when the scores of in a distributions are more or less systematically grouped about a central point. When the research problem requires a measure of central tendency, that will also form a basis for the other statistics such as measures of variability or measures of association. When the research problem requires the combination of mean with the means of other groups measured on the same variable to measure the central tendency in a sample of observation, when other one needs to estimate the value of a corresponding mean of the population from which the sample is taken. When the interval level of ratio level of data providing the distribution of scores approximates a normal curve, use the median. When the research problem calls the knowledge of the exact midpoint of the distribution, when the extreme scores are there in the series as they distort the means but not the median, particularly when dealing with the oddly shaped distributions, for example those in which a high portion of extremely high score occur as well as a low portion of the extremely low ones. Use the mode when all that is required is a quick and appropriate way of determining the central tendency. When in referring to what is average, the word is used in the sense of typical or the most usual. For example, in talking about the average take-home pay of the coffee plantation worker, it is the model where average that is being alluded to rather than the exact arithmetic average. So reflections and action 16.3. Provide examples of data that requires mean, median and mode types of calculation for reflecting the central tendency of the data. 16.7 conclusion. Succinctly, mode would be the appropriate statistic to use as a measure of the most fashionable or most popular when data are collected using a nominal case. Median would be generally be associated with the ordinary level data. Mean will be used with the interval levels of or a ratio level data, providing that the distribution of scores approximates a normal curve. You can take mean to be a mathematical measure and median mode to be a positional measures. You can always cluster your observations around a central value. A central value manifests both the distributions of comparisons of various distributions. It is always useful for a researcher to provide measures that incidence the average features of a frequency distribution. Unit 16 has discussed the three measures of central tendency and provided skills of basic statistical tools for applications in your research. It would have become apparent to you that the three measures of the central tendency, namely average of all the values in the distributions or mean, the midpoint of distributions or mean, and highest destiny in the distributions of mode, are not be applied in a mechanical way. In the light of the objective of your study, you would need to determine when you are to use which measure. You have learned in Unit 16 that a graphic representation of distributions shows either a symmetrical or a skewed pattern. In a symmetrical type, you will find the three values coincidence. This provides you the opinion of using the mean. In the case of bimodal or multimodal representation, you would do better to use the mode. In skewed distribution, if the tail is on the right side, it is indicate the positive skewing of distribution. If the tail is on the left side, it shows the negative skewing of distribution. For both the negative and positive type of skewing of distribution, you would do better by using the medial measure of central tendency. You may want to work out with the help of Unit 16 the types of measure of central tendency you will use in your mini research project. Further reading, Black Thomas are doing quantitative research in the social science, an integrated approach to research design, measurement, and statistics. Nachimias, David and Chava Nachimias, 1981, Research Methods in Social Science, St. Martin Press, New York. This is the end of the unit 16. Thank you very much.